Hey guys, we are finally to the rocket launch, and unfortunately, this is not going to be as exciting for you guys because I can't safely send home a rocket for you to launch off unsupervised. So, what you guys will end up doing, fix this a little, uh, is I'm going to give you guys the same lab with some like pre-subbed in information so that you guys have the same results, around the same results as what the kids in class should have. So I'm going to walk you through this real quick, but basically, you guys are missing out on the fun part of this, unfortunately, but you'll still get the same like math review. And this is kind of our end of the unit lab. So I did send out an announcement earlier today. It's kind of talked about the next couple days, the next week, but so anyway, kind of how this is going to work with all of the classes is that for in class, we are going to be building the rockets, and then that's going to take a couple of days because they have to cut out pieces and glue them, and I have to wait for it to dry and all that. And then we'll go out and launch them. So that's going to be a 3-day process. We're going to spend the first day doing the pre-lab and starting to prep the materials. The second day is going to be just building, because some of these rockets they'll get done soon, but some of them will need a full 2 days. And the third day, we're going to go out and launch the rockets from like the soccer field area. So even though you guys don't get to do all that part, which kind of stinks, but you guys will have kind of extra time. So there's a benefit to that, because obviously you probably don't need 3 full class days to do the math portion of this, and you aren't building one. So I'm going to walk you through it. So we have here on the screen, we've got the rocket projectile motion lab. Just zoom this in a little more. Some of our learning objectives for this lab are talking about just analyzing the two-dimensional motion mostly. So we're talking about the different variables involved in angled projectile motion, and finding a lot of the horizontal and vertical displacements and the measuring the hang time and stuff like that. So there are some diagrams on here from Estes, which is the company I got the rockets from. Just some recommendations of launch areas, just things you might want to go look over. So the intro is just going over what this is. So we have 3 different models of rockets. You can pick one of the 3 models and use that model as your reference. So those 3 models are down here. So we have this like little picture here at the bottom. This is a picture of the box, and then I added in some hang times for you guys. So what we have here is we have the Alpha, the Viking, and the E2X. So these are 3 different types of rockets. You can pick whichever one suits your fancy, and we have like the vertical height they should reach, the hang time, some other information about them that you can use in your calculations. For the formulas here, I have inserted all the formulas that you should need for this. And what we would do if you were here, so we would build the labs, and then we're going to build the rockets, go out and launch them at 90 degrees, so straight up in the air, and at 45 degrees, and kind of compare the trajectory, see how wind affected things, and see what the horizontal distances were. So as we go through here, you guys do have your pre-lab, and you are not receiving your rocket kit, so ignore that line. But I did edit this, so this does not look the same as everyone in class, because you guys don't need like the whole procedure and all of that too. So you guys do have a couple of questions here to answer, and this one I kind of wanted to talk about. So if there's 0 air resistance and you shot something straight up in the air, it should come straight back down. Okay, so if there's nothing, no other forces acting on that object other than gravity, if you throw it straight up, it should come straight back down. So ideally, when we launch these rockets straight up in the air, in a perfect world, they would come just straight back down and land with 0 horizontal displacement. That obviously is not going to happen, and there's multiple reasons for that. So in this question, you want to address those reasons. So did we have a lot of wind? Like, you can check the weather. We're launching these on Friday and Monday of like Friday of this week and Monday of next week. So look at the weather. What's the weather look like? Do you think that's going to change anything for the launches? The different shapes of the rockets, they have different aerodynamics. They have different size parachutes. And, something could happen. What if the parachute gets hung up? Or, there's a lot of different things that could happen. So I want you to think about that one. And I know you're not actually going to be seeing it happen, but I'm sure you can kind of give me a thoughtful answer for what you think will be the reason for that. So then just some more questions about kind of like launch angles. What do you think the shape, if you drew it out, or even the actual shape of it would give you? Number 3, this is where it's important to have your rocket model that you chose, like that's what you're going to be referencing it for, is for these questions. So whichever model you chose, like if you chose the Viking, you would look at this table at the top here and find your distances. These are in meters because we're always using meters. These are giving you your delta Y, your vertical distance, hang time. That's all you need for these. So you'll plop that in here. You'll figure out which formulas you need to find the initial velocity for number 3. And then once you find the initial velocity, you can determine the horizontal displacement of your rocket. So you should have what you need for those. So we have some other things like what factors could change things, what safety precautions should we follow, just based off of what you know from the safety contract. And then down here, I've taken out the whole in between section of the procedure because you guys just don't need it. It just was talking about building the rockets and, like don't put the engine in until you're supposed to, like no launching it. If you launch it without permission, you're going to be in trouble, that kind of thing. So you don't need that. So on the data collection, I have entered in this blue information here for you. These should be comparable to what we're getting in class. So you should get comparable answers for that. So you have all these 4 variables that you're trying to calculate. So you're going to find the vertical velocity, the horizontal velocity, and then the resultant velocity or the initial velocity there. So this diagram this type of graph was on the last set of slides that we went over, on like the very last couple of slides from this unit. It, for the first angled projectile motion slide, it had the Y and the X velocity, and then the third one coming straight out of like the center. So that's your resultant velocity, which is a combination of your vertical and horizontal velocities. So you're going to find your Vy, which is vertical, Vx, horizontal, Vi, which is your resultant of those two. It's also the initial velocity. I guess this is V1. We've been using 1, sorry. And then you're going to find your maximum height, so the delta Y on this. So again, you guys have these formulas up here, and you can use them. So the same ones you guys used from the last set of homework. So I plugged that in. So like I said, we're launching it from 2 different angles. You do need to show your work, okay? So if you don't want to type it out on here or write it out on here, that's fine. But you do need to do it on a piece of paper and show your work. The answers still need to go in this data table, but you do need to show your work. Make sure it's labeled so I can tell which one you are calculating. And if you take a picture of it, of a piece of paper, make sure you upload it with your assignment. And more space to work, there's a whole extra page in there. Down here, you guys are going to be drawing your vector diagrams. So we've been drawing vector diagrams kind of for a little while now. So make sure you're labeling these 3 velocity components, the angle. You want to label your horizontal distance and your peak, or your vertical distance. So you're going to have one for each model at each angle that it was launched. And these are at 45 degrees. I got to change that. Then the last part of this is going to be just some analysis questions. So which rocket had the highest peak? Why do you think that? Again, you can go back up here and look at these. These give you a lot of information. We're using the same engines in all of these rockets, so they're all going to have the same amount of thrust, the same amount of force pushing them. But you can see that their weights are different. the dimensions are different. So think about that when you're answering these analysis questions. Then, let's see, you're comparing the actual results to the results you calculated, talking about which type of velocity has the greatest effect, and then a conclusion. So the conclusion's going to look a little different from someone that was in class, obviously, because you guys will not be talking about the procedures. You're not going to have anything that you actually saw happening that could have gone wrong, but you do want to analyze the results. So look at the data tables and kind of you can see some kinds of trends there. Compare that to the sizes, like the dimensions and the weights of the rockets, and maybe compare that to their horizontal distance. You can address any possible errors that could have happened. So, there's lots of things that could happen or go wrong with a rocket launch, or things that could affect the trajectory of a rocket in the air. And if you are struggling with that and you're not really sure what to do, you can go to the Estes website and you could look up the 3 models we use. There's a lot of information on their website about model rockets and like launching them. So there's a section for students on their website. It's like a drop down at the top. Lots and lots of information in there. So if you're struggling, trying to like visualize this, you can visit their website and get some examples and just some more information from them. And that is it. So it really stinks that you guys can't do the whole project. If I could send you home rockets to launch off at your houses, I would. Pretty sure I can't do that. So I guess the only upside is that you guys will probably have an extra couple of days where you aren't working on things. So if you need to, you can use that time to catch up. But this is what we'll be working on until like mid next week. So we'll work on this today and tomorrow. We'll work on this Thursday and Friday, and then Monday and Tuesday. Am I getting my days right? And then Tuesday should be like our launch day. So then Wednesday and Thursday, the lab will be due, and we'll be doing review for Unit 2. And then the Unit 2 test will be next week on October 23rd. I'll open it on the 23rd, and it'll close on the 26th at midnight. So you guys will have from first thing in the morning on Friday the 23rd, all day on Friday, all weekend, all day on Monday until midnight. It'll close at midnight for that test. So that's where we're at. If you guys have any questions, please let me know. There will be some other things up in the module, like a map of where we're going to go to launch it off, like the safety contract part of it, things like that. So it'll all be on Canvas. You're already on Canvas, so just check it out and make sure that you see everything that's there. So let me know if you guys have questions. If you need to make a Zoom, we can. That's it. So have a great rest of your week.